Hi, I am Ms. Tawalba. We are very sorry for not being able to attend the conference for visa issue. In this presentation, I will present our work via this recording, and if you have any question, please contact with us via emails. We will go through introduction, then problem definition, then fake news detection, and we will have some related work to talk about. And then we will talk about our approach. Finally, we will discuss the result and conclusion. Internet services and applications have been involved in spreading fake news all over the world. Recently, social media has become one of the main sources of information. The main factors beyond this are low cost, the speed of access, ease of use, and availability of digital devices like desktops, smartphones, iPod, and others. The fake news concept refers to intentionally disseminate false information. It aims to confuse and mislead the readers to achieve economic or political agendas. In the past, and before the born of the Internet, we got our news from traditional sources, such as newspaper, radio, or television. However, the Internet has enabled a wholly new way to publish and broadcast information and news with less regulation. Fake news became a common concept that has grown in popularity. This definition has two main characteristics: authenticity and intent. In the first characteristic, fake news includes false information varied in their content that can be verified. The second one, fake news, is created with dishonest intention, aims to mislead consumers. The rapid growth of a players' number in a news spreading field, especially on social media, has led to an increase in the number of news which are hard to tell if they are credible or not. So, the common way to highlight a specific type of news is by choosing a headline that grabs the attention of readers. Unfortunately, the news content doesn't always reflect the headline. The researchers studied this problem by analyzing several data sets that are focused on instance and headline detection tasks to identify whether a news headline is in reality related or unrelated to the corresponding news article. In the previous work, there is a classifiers that detect fake news, such as SVM classifier and a neural network. Our approach. The dataset is derived from the emergent dataset created by Silverman. It is used in February 2017 for Fake News Challenge Stage 1 for instance detection. The dataset is provided as two CVS files, trend bodies and trend instances. As shown in the table, the trend bodies files has 1,683 records, each one with two attributes, article ID and article body. The trend instances file has 49,972 records, each one with the three attributes, article ID, article title, and the label. As we mentioned before, we have different number of articles and headlines in the dataset files, so we have used many-to-many mapping. As a result, we got 49,972 pairs of headline and body texts, each with corresponding class label. In the next step, we divided the datasets into training set with 60%, validation set with 20%, and test set with 20%. The class label of the dataset distributed to four classes, which is agree, disagree, discuss, and unrelated. And here in the chart, we can see the distribution for each class in the whole dataset. In order to extract features from text data, we have transformed the input into vector space. Using pre-trained word embedding models, we have used Jensen model and Google News. As a fast comparison between them, Jensen model is trained in our dataset, which is roughly 9,072 records, while Google News model is trained on roughly 3 billion of words from a Google News dataset. Based on outcoming result, we adopted Google News model in our experiments. We ran over tens of experiments across different neural network architectures and hyperparameters. Two models show satisfying results named Fake News Detection Bidirectional LSTM Concatenated Model, Fake News Detection Multi-Head LSTM Model. The number of layers and units which are included in the models have been chosen after applying several experiments. In this slide, we show our model details. The first model is Fake News Detection Bidirectional LSTM Concatenated Model. In this model, the headline and article text are converted into two separated embedding layers using Google's pre-trained model. Then, the result of the two embeddings vectors are concatenated to feed the model. The model contains two CNNs layers with 32 and 64 filters respectively. The CNNs are followed by max pooling to avoid overfitting, before passing it through a bidirectional LSTM layer with 100 memory units. The output of the bidirectional LSTM passed through 3 dense layers with 512, 128 4 units. These layers separated by one dropout layer. Then we use a softmax activation function in the output layer to classify the stances into 4 classes. Through the training process in this model, the loss function used was sparse categorical cross-entropy. The second model is Fake News Detection Multi-Head LSTM model. In this model, the merging of headline and article text occur before passing them as input through the input layer. Then the embedding layer using Google pre-trained model is performed. The embedding layer resulted from previous step is passed through two CNNs layers with 32 and 64 filters respectively. This step is followed by max pooling to avoid overfitting. Then the output is passed through 5 multi-head LSTM layers with 150 memory units. A flattened layer is added. Then the results are passed through one dense layer with 4 units and a softmax activation function to classify the stances into 4 classes. The loss function in the training process was sparse categorical cross-entropy with Adam optimizer. Our results. We used the online Python environment Colab, which is provided by Google. We tried different hyperparameters, loss and optimizer functions to achieve the best results. This table shows the statistics for our models. The Fake News Detection Bidirectional LSTM Concatenated Model gives the best accuracy. This shows the loss function and accuracy for training and validation sets over time for our best model, Fake News Detection Bidirectional LSTM Concatenated Model. And here we can see the confusion matrix for the best model. The conclusion. Nowadays, sharing information is getting easier due to the evolving of new trends in computing. Using online platforms to spreading fake news become very popular. So, there is an increasing demand for an accurate and efficient fake news automated detection systems. In this research, we proposed an automatic identification of fake news model using modern machine learning techniques, mainly deep learning and neural networks. We explored in detail two models. The results showed that the bidirectional LSTM concatenated model has the highest accuracy with 85%. And the precision of 77%, followed by the multi-head LSTM model of about 83% accuracy and 85% of precision. Overall, we recommended using the multi-head LSTM model. Finally, thank you for your listening. And for any question, please contact us via this email.